I'm Harrison Falkowski.
And I'm Wyatt Blanks with the Stewart's Creek FFA chapter. In 2016, there were 10,000 acres of hemp planted across America. In 2018, that number rose to 78,000 acres. So in just 2 years, that number increased eightfold. Coming into this project, me and Harrison really didn't know too much about how hemp was produced and how it's processed, but we really knew about CBD oil, hemp rope, things that really everybody knows. We also learned that hemp farmers are losing a lot of money every single year. The reason they're losing a lot of money is because the processing facilities that are supposed to process their hemp for them, they're simply not doing it. For example, in January of 2019, the Boring Hemp Company sued their processing facilities for violating their contract.
This is happening nationwide. It is proving to be a huge problem for hemp producers across the country. Up to 90% of hemp is being left in the field to rot every year because producers can't find ways to process it after being harvested. This is estimated to cost the industry around $8 billion. We wanted to find new ways for hemp producers to be able to make money without their plant being processed, and this led to the idea of using hemp as a source of livestock feed. Our project is a feed analysis of cannabis sativa seed varieties as a source of revenue for hemp producers. Our experiment consisted of a nutritional analysis of 4 different types of hemp seed varieties, being whole hemp seeds, ground hemp seeds, hemp hearts, and hemp hulls, and a comparison of the 4. The scope of our experiment was to determine whether or not hemp could be used as a viable source of livestock feed. We hypothesized that ground hemp seeds would be the best source for livestock producers.
This project is geared towards the future of the hemp industry, considering it's only legal to feed hemp products to livestock in Tennessee and in Colorado, but we both foresee this becoming legal in all 50 states sometime pretty soon. This is why we opted towards doing a nutrient analysis of the seed varieties compared to feeding to live animals, but it's something we're looking into as an extension of our project.
One of the many skills we learned in our experiment was how to identify different nutritional requirements for animals to maintain optimal health and growth. One of our main sources of the collaboration was Mr. Joe Sparrow of Rock River Laboratories, who helped us identify that crude protein, energy, and total digestible nutrients were the most valuable factors in our experiment. Crude protein and energy are a measurement of the animal's growth, maintenance, production, and reproduction levels, and total digestible nutrients is the level of nutrients an animal can absorb from a feedstuff. For example, if a feed has a 100% crude protein rate and only a 10% total digestible nutrient rate, the animal can only absorb 10% of that crude protein. Mr. Sparrow was extremely valuable in our experiment as he gave us insight into the feed rationing industry, helped guide our experiment, and helped us with being able to use a unique commodity.
Another skill we learned was how to compare different feed sources to one another. We were able to collaborate with our animal science teacher, Miss Amy Alt, and she helped us determine whether or not producers of livestock would actually feed hemp products to their animals in the first place, or if there would be any concerns surrounding that. We also collaborated with Dr. Kelly Chastain, the Rutherford County Science Specialist, and our agri-science teacher, Mrs. Gina Stewart. They helped us maintain scientific accuracy and stay on course and pretty much just made this whole thing possible. As me and Harrison don't have $30,000 to spend on processing equipment for the hemp, we collaborated with our high school peers and broke down the hemp by hand. It took a while, but for the sake of this project, it worked just fine.
Although our hypothesis was not supported, we concluded that hemp parts were the most viable source of livestock feed by comparing the different rates of crude protein, energy, and total digestible nutrients of the 4 different types of hemp seed varieties. We found that hemp parts, as seen in blue, had the highest rates of crude protein at 37%, highest energy at 39%, and had the highest total digestible nutrients of 75%. Compared to the mean of different types of hemp seed varieties, as seen in purple, the hemp parts had a higher crude protein by 9%, a higher energy by 9%, and a higher total digestible nutrients by 10%. Our research was conducted with a scientific accuracy of 95% to ensure our experiment was valid. Additionally, with the hemp parts being a soft, flaky material with less surface area than the other hemp seed varieties, it makes them more digestible for livestock because they don't have to chew as much. We also found that hemp hulls were a viable source of fiber.
Our project will impact agriculture from a variety of standpoints. This will create a whole new commodity for livestock producers to feed to their livestock, while at the same time it gives hemp producers a new source of revenue. Another thing to take into consideration is with the Phase 1 trade agreement with China. Pretty much, they said that they would buy $80 billion worth of agricultural commodities over the next 2 years. So this will take the already booming hemp industry and grow it exponentially.
The possibilities with this experiment have been limitless. In the future, we hope to run an extension utilizing live animals.
We also just want to thank you for your continued support of this organization. Without your collaboration, this whole contest wouldn't be a possibility. Thank you.